To understand the nature of planet Earth, we must study the powerhouse at the center of the solar system, the body that heats and lights our world, on which everything, including humankind, depends. The Sun. The Sun is a star, an enormous nuclear reactor generating prodigious energy. Swirling magnetic fields, dark regions called sunspots, and searing eruptions of flares and prominences. Triggered possibly by the shock waves of an exploding star, the story of the Sun began some 5,000 million years ago, a whirling cloud of gas and dust that became increasingly concentrated. Within the cloud was all the material necessary to form the Sun and the planets. As the cloud condensed, so its central gravity increased, a vast aggregation collapsing on itself. The densest material at the center became intensely hot and nuclear reactions began. An embryonic sun had formed. Meanwhile, throughout the rest of the cloud, great swirls of material were shaping the 9 planets of the solar system. Today, the Sun is middle-aged, one of the 100,000 million stars in our galaxy, the Milky Way. Compared to Earth, it's gigantic. With a diameter of nearly 1,400,000 kilometers, the Sun is over 100 times wider than Earth, 1,000,000 times the mass. Even sunspots are several times bigger. The secrets of the Sun are revealed in its light, beams that can be caught and analyzed in solar observatories. Sunlight is a rainbow of color, a spectrum. Break it down and dark lines appear, fingerprints of the elements which make up the Sun. And they give us other clues to temperature, speed of rotation, magnetic activity. Here, the red fingerprint of hydrogen. This time-lapse, which filters only red light, reveals a Sun composed 3/4 of hydrogen, 1/4 of helium, and rotating in 27 days. Surface temperature, 6,000 degrees Celsius. In imaginary cross-section, the temperature at the core is 15 million degrees. Every second, nuclear fusion turns 4 million tons of hydrogen into helium. The energy produced takes eons to reach the surface. A total eclipse is another aid to solar study. It displays the tenuous outer atmosphere of the Sun, the corona. This is time-lapse of an eclipse from Java. The Moon, in orbit around Earth, is passing directly in front of the Sun. Only when the eclipse is total will the corona appear. As totality approaches, a strange twilight descends. Observers have trekked from many parts of the world to witness and record. And there's a diamond ring corona, just ahead of totality. The Moon now covers the Sun. An exposure change, and with it, the full magnificence of the corona. We're looking at a halo of hydrogen particles extending millions of kilometers into space. Totality was to last 5 minutes, 7 seconds. Precious moments, for the corona is so sparse that it's glimpsed only when the glare of the sun is obscured. Yet another way of looking at the sun is in soft X-ray. The small image is the same picture in visible light. They show the intense activity of sunspots. Sunspots are probably caused by powerful magnetic force lines. They're tangled and distorted by the sun's rotation and by its churning surface, the yellow photosphere. In close-up, the dark areas are sunspots. The bright regions, thousands of heat bubbles, each measuring 800 kilometers. This sunspot appears dark because it's 2,000 degrees cooler than the surrounding photosphere. The center is called the umbra, its edge the penumbra. A group of sunspots. They take up to 10 days to form and 2 weeks to fade. In quiet periods, there may be no spots at all. These sunspots were filmed in 2 different wavelengths. Here in visible light, now in the red light of hydrogen alpha. Both show huge arcs bent around magnetic force lines. The whale's fin is a prominence, the silhouette of a gigantic billow of gas. And there's another. Such plumes lick right through the sun's atmosphere, the red chromosphere. This one in black is set against the bubbling photosphere, the sea of firestorms at the solar surface. Prominences can extend 1,000,000 kilometers, this one suspended in a magnetic arc. But the most spectacular phenomena are flares, eruptions with the energy of 10 billion megaton bombs. Bottom left, shock waves radiate from an exploding flare. Remember, the sun is a gaseous mass. Flares eject stupendous quantities of material at millions of kilometers per hour, energized particles hurtling outwards as part of the solar wind. On Earth, they can disrupt telecommunications, but largely they're deflected by Earth's magnetosphere, except at the poles. There they create auroral rings as the particles are drawn earthwards. From beneath, the result is spectacular, the aurora, charged solar particles reacting with the atmosphere like a giant television tube. From the interstellar cloud that formed the solar system came not just the sun, but the 9 planets. As the heat of the sun increased, so lighter elements were driven outwards. They'd form gas giants like Jupiter and Saturn. Heavier material nearer the sun condensed into the inner planets, including Earth itself. Our embryonic world whence sprang life and humankind. We are truly children of the stars.